This is the Comparative Anatomy Evidence of Evolution activity. The directions say, open the Vertebrate Structures PDF, which I have open here. If you don't have this open, make sure it's open. If you need to pause the video, go ahead and do that. This PDF has 5 main sections. The first one is Appendages. The second being Movement on Land. Third is Aquatic Animals. Next is Wings. And finally, the Cambrian Explosion. So this is going to be the source of our data as we answer these questions. The first bullet point says, take observations about each set of information. For example, when looking at the Appendages section, what observations do you have? What could your observations tell you about the evolution of vertebrates? Okay, so I'm noticing the same 5 sections below match the 5 sections in the PDF that I just had open. I'm going to jot down my observations, things I notice or clues that could help me answer the question, what order did vertebrates evolve in? And then I'm going to think about what those observations could tell me about the evolution. Now, before we dive into this too much, it is important that you've taken the time to really understand the notes on this section. So I jump forward a little bit in the slides, but here's the big ideas. Structures, or the parts of an animal, can be evidence. And in fact, scientists look at structures for clues of evolution. Animals with similar characteristics often share a common ancestor. So if I see 2 things with fins, it's probably because they got those fins from an ancestor. Or if an animal's lungs or heart are shaped in the same sort of way, it's probably because their ancestor had that heart. However, not all structures show evolutionary relationship. In fact, there's 2 types of structures. One set are homologous structures. These are structures that are similar in related organisms because they inherited the trait from a common ancestor. So it might be that they have the same sort of structure of bones. Seen here in this picture, the structure of the bones is the same. And they may or may not have the same function. For example, a lizard's leg and a bird's wing, while the bones are the same between the 2, the functions are very, very different. Lastly, we have analogous structures. These are where you have structures where similar in function in unrelated organisms. So that means 2 organisms that are not related, they do not have a common ancestor, but their structures appear very similar. The reason they're similar is because they do the same job, not because they have the same ancestor. A great example would be, think about flying insects. A dragonfly flies, a butterfly flies, a bird and a bat fly. However, insects and birds and bats have very different common ancestors. So even though those structures of the wings are similar, it's not because they have a common ancestor, it's because they evolved to do the same job. Now that's really important as we go through these notes. So again, back here, I'm going to be going through the 5 sections, jotting down observations, and then thinking about what that could tell me about evolution of vertebrates. Let's do the first section together. First section is just called appendages. Remember, that's things that are stuck on your body, arms or legs or wings. An appendage is a part of the body that projects or sticks out of an animal and serves a function. Arms, legs, wings, and fins are examples of appendages. Below are the bones that make up the appendages of all 5 types of vertebrates. Again, those being amphibians, reptiles, mammals, birds, lizards. Reptiles. Humans, cats, whales, and bats are all mammals. Okay, so humans, cats, whales. Lizards are reptiles. Frogs are amphibians. And birds, well, birds are birds. All right, so I'm taking a look at these bone structures. I'm noticing right off the bat that there's the same sort of pattern of colors. I see a bone in white, followed by a pink and a gray bone pair, followed by some dark gray bones, followed by some orange bones. Okay, so I'm thinking about these are the bones in a human arm. All right, so here's the top of my arm. Here's the lower part of my arm, or my forearm. Here's my hand. This is a lizard's leg. Interesting. So they have a similar sort of bone, 2 bones, and then some fingers. A cat. I look very different than a cat, but when it looks at just its bones, I see the same, like 1 bone, 2 bones, these finger bones. Even a whale, inside their flipper, which is not used as a leg or an arm, seeing the same sort of pattern. Bats fly, but again, there's that 1 bone, these 2 bones, and then these fingers. Even a frog and a bird. Interesting. I couldn't think I could be much further away from a bird, but if I looked at just their bones, I'm starting to see a pattern here. Turns out these are actually even the same named bones. That first bone is the humerus. You might remember that from our human body unit. The next 2 are the radius and the ulna. Maybe you'll remember back to Layla and that engineering. The next ones are the metacarpals or the carpals. Those are the wrist bones. And then finally, these dark orange ones are phalanges or fingers. So interesting. I'm noticing that all these organisms have the same set of bones, even though their functions are very different. Now that sort of observation is something I could put in here. Maybe I'm going to use a bulleted list just to make it clean. All the vertebrates have the same set of bones. And I'm going to simplify and just say 1 bone, connect to 2 bones, connect to the wrist, connect to fingers. I might also notice, like the sizes are very different, but the order is not. I'm also noticing a human hand, a lizard leg, a cat leg, a whale flipper, a bat wing, a bird wing, and a frog leg. All the same structures serve very different purposes. All right, so here's my observations. All the vertebrates have the same set of bones. The sizes are different, but the order's not. And they're all the same structures, but they serve very different purposes. So thinking back to the slides, this tells me that the bones of the limbs of vertebrates are homologous structures. This means, misspelled. This means that all vertebrates must have a common ancestor that had the same bone structure. It's honestly quite impossible that you could have 5 different groups of animals all evolve the exact same bone structure. Really, the only way that's possible is if they had a common ancestor that had that 1 bone connected to 2 bones connected to the wrist and the fingers. If they all had that ancestor, that would make sense why they all have the same bone structure. Now, this sort of reasoning, so looking at the evidence and jotting down notes, and then thinking about what that tells us, is what we need you to do for the next 4 sections. Again, you're going to look through the evidence and think to yourself, what do I see? What similarities are there? What can this tell me about their evolution? And once you have those observations, go ahead and think about what it might mean about the evolution of vertebrates in general. Or maybe more specifically, you could start thinking about which vertebrate evolved from which other one. Did mammals come from birds, or did reptiles come from amphibians? And again, if you're really stuck, you can always reach out via text or call or email. Hopefully this helped, and good luck.